I've selected 3 cos functions and I want to show you how these 3 cos functions differ. And these 3 functions are an examples of composite functions where we have a function within a function. Before we look at these functions, how they differ, I want to show you the rules of differentiating trigonometric functions. So from this table you can see that a function sin x, when differentiated, becomes a cos x, and a function which is cos x will be differentiated to become a minus sin x. Now our functions are all cos, so they will become minus sin x. But as I said, they are examples of composite functions. Let's look at that first function. In this function, the x squared is the function within the cos function. So first of all, we will differentiate the cos function itself, which becomes minus sine x squared. After which we try to differentiate that function x squared. So let's say that x squared is u. Then if we differentiate u, it'll be just 2x. In other words, we'll just multiply this by 2x. And we can rewrite, therefore, our function, differentiated function, as minus 2x sine x squared. Now I'm going to look at the third example here. Y is equal to brackets cos x bracket with a square. And this time our function within is going to be once again the one inside the brackets, which is cos x. In other words, our u is going to be cos x. And if we differentiate cos x, as we said above, it becomes minus sin x. But our first job is to differentiate what's outside the brackets. That means we have to take the 2, put it in front, leave what's in the brackets, cos x, and diminish the 2 by 1 so that it'll become just 1. Now we're able to differentiate the inside the brackets, which is the cos x, so we can now multiply this by minus sin x. And this could be more concisely rewritten as minus 2 sin x cos x. And by differentiating these two, we can see that the answer is not the same from one to the other. So what about the middle one? Easy. The middle one is exactly the same as the last one. It's just another way of writing those two functions. Now, why would we want to sometimes write it with brackets outside and sometimes with the square number just after the cos x? So writing, for example, a function such as cos 4x squared is ambiguous because we don't know whether the 2 refers to the 4x or does it refer to the whole function. In other words, we don't know whether it means y is equal to cos 4x and just the square refers to this, or do we mean that it is cos 4x but it refers to the whole cos 4x? adding these brackets can sometimes be a lot of work. So if we were just to write it down as y is equal to cos and put the square in here, we now don't need to put in those brackets. And that's just a shorthand of writing and saying that this is exactly the same as this. Well, I hope that this was useful. And if you did find it helpful and useful, then please subscribe to my channel and you'll be notified as soon as I make another video.